What's up, guys? In this video, what I want to do is help you solve a system of equations from a word problem. And we're going to do that by going through 5 different examples that I have hand selected to help you out through the process. I hope you enjoy.
This one says a family of four adults and 3 children spends $47 for a movie ticket. Another family of 2 adults and 4 children spends $36. What is the price of children's tickets in dollars? So again, we need to identify our variables. Now, they're only asking for what the child ticket costs for. However, we know that there is the cost of a child's ticket, and y would represent the cost of an adult ticket. So there's going to be 2 variables. Do you guys agree with me? Yes? So if you have, we know that, let's say 3x plus 4y is equal to $47. Do you guys see how it's kind of different in this situation? It's equal to, whereas that one, it could have been 15 cargo, but it could have been less. That's why we use the inequality. And then the other one would have had 4x plus 2y is equal to $36. Now again, what is the only variable they're asking us to solve for? Right, so which variable would that be? X. So they're only asking me to use x. Now, should I use substitution or elimination? You're going to want to use elimination. And we don't need to solve for x and y. We just need to solve for x. So what I would do in this case, if you guys remember, you got to get the variable to have the same coefficients. I like to have one positive and one negative. So we need to find the LCM of 3 and 4, which would be 12. So I'll multiply the top by a negative, or you could multiply the bottom by a negative. Therefore, I get negative 12x minus 16y equals 47. That would be 94, 188. 94, 188. Somebody could check my work for me. Negative 108. OK. 3 times 4 is going to be 12x plus 6y is equal to 36, 72, 108. Now, since I have multiplied them, I can add my 2 equations. And I end up getting negative 10y is equal to negative 80 divided by, oops, what am I doing? Oh my God, I'm solving for y.
Isn't it like 6x plus 12y?
All right. There's nothing wrong that I did, but the problem is, ladies and gentlemen, I isolated the x, right? I eliminated the x. X is what we're trying to solve, right? So even though there's nothing wrong with the math I did, that's telling us how to find the adult ticket. We don't care about the adult ticket. We're only asking us for x. So we want to eliminate what the adult ticket is. So I'm just going to multiply the bottom equation by negative 2. I apologize. I'm doing so much more work than I needed to do. So if I just multiply the bottom equation by negative 2, I get a negative 8x minus 4y equals a negative 72. Therefore, this gives me a negative 5x equals a negative 25. Divide by negative 5, divide by negative 5, x equals 5. So therefore, a child ticket costs $5. So anyways, ladies and gentlemen, anytime, the reason why I want to make a video, at least over this, is just remember, anytime you guys are seeing any kind of words or anything like that where you need to create the equations, make sure you guys define the variables. So basically, the best way to define the variables is not really that difficult. All you really need to do is go to the question. How many of each bill do we have, or does he have? So all we're looking for is how many he has. Well, what? He has $5 bills and $1 bills. So I'm just going to say x equals the number of $1 bills, and y equals the number of $5 bills. You could have switched the x and y's. That's perfectly fine. You could use You could use m and n. You could use a and g. Whatever. Doesn't matter what variables you are. As long as you understand they represent the number. They represent how many. So once we find that number, it's going to tell us how many of each. Does that make sense? So we know there's two things. Now, when you're solving a system of equations, whenever there's two unknowns, there's two things we don't know, you have to have two equations. Okay? So if there was three unknowns, you'd have to have three equations. But anyways, so we know that he has a total of 15 bills. Remember, total represents the sum. So x plus y equals 15. Now remember, that represents how many, right? Or here, let's do, yeah, that's basically the, actually, how many. That equation represents how many total he has. And then the next one is he has, the worth is $47. Well, each $1 bill has a worth of 1. Each $5 bill has a worth of 5. And that equals 47. Now, I'm not going to use the dollar signs. But what I want you to talk about is this is how much they're worth. So there's two different equations that represent totally two different things. One, x plus y equals 15, just represents how many bills he has. And the other one represents their worth, right? Each $5 bill is worth $5. Each $1 bill is worth x dollars. And their total worth is $47. Do you guys see how they're related, right? One talks about like counting the number. The other one talks about worth. So I kind of grouped them together. Now we just solve the systems of equations. So again, we need to pick a variable we want to isolate. I'll isolate the x. If you isolated the y, you'll get the exact same answer. So if I was going to do this, I would just take, so step number 3 is going to be x plus y equals 15. I'll subtract y, x equals negative y plus 15. That is my quantity that I'm going to plug in for x in the other equation. So when plugging that in, I get negative y plus 15 plus 5y equals 47. I'm not really multiplying anything by my x, so I don't really need the parentheses. So negative y plus 5y is 4y. So I have 4y plus 15 equals 47. Subtract 15, 4y equals 32. Divide by 4, y equals 8. So there was 8 $5 bills. Anybody else get that? Yes? Good? All right, perfect. So now we know how many $5 bills are. To find out how many $1 bills are, we have this equation where x is already isolated. So now I'll just take what y is and plug it into this equation. Plus 15. X equals negative 8 plus 15 is 7. So you have 7 $1 bills.
Ladies and gentlemen, let's go ahead and take a look at doing this problem. Now, there's an important thing that I want you guys to understand when we're doing a word problem, just like we did with the 4-step problems. Word problems are just like the ACT. The reason why we spend a lot of time with the ACT and stuff like that is to take a problem like this and understand what exactly are we trying to figure out. So whenever you're dealing with a word problem, because it really frustrates me, you know, we get to word problems, a lot of you will just shut down because you're like, oh, I know this word problem is going to be too tough, you know, for me to handle, so I'm not even going to try it. But let's try to break down the word problem into smaller steps and see how feasible and actually easy the problem really can be to go ahead and create. The first thing I think you need to understand when doing a word problem is understand what exactly they are asking. So usually at the end is kind of where they get to tell us, and we just need to focus on that. It says, how many of each room does the hotel have? So we need to understand, so there's rooms, right? We need to know how many, right? How much? How many? Well, what type of rooms do we have? So we go back through the information, and it says there's rooms that have a kitchen, and there's rooms that do not have a kitchen. So therefore, there's two things that we need to find how many they have, right? Right? That's what we're trying to figure out. We want to know how many rooms have a kitchen and how many rooms don't have a kitchen in the hotel. So to find those values, I need to assign them variables. All right? So I can say x equals the number of rooms with a kitchen, and y equals the number of rooms without a kitchen. Does that seem pretty simple enough? We need to know how many, so that's why I want to know the number.
right? That's what we're trying to figure out. But the thing, guys, the whole key to being able to solve this is identifying your variables. Because once we have variables, to solve for variables, we need to create equations. And this is usually the most difficult part of the process, is creating these equations. Well, one equation says the hotel has a total of 200 rooms. So if you had, you could have 100 rooms with a kitchen and 100 rooms without a kitchen, right? That would be 200. So you're adding the number of rooms together. So I can just say x plus y equals 200. That's one equation. The next equation is going to be a revenue equation. And if you think about it, they said, a room costs $100 a night. So if you have one room, you get $100. 2 rooms, there's $200. 3 rooms, $300. And basically what you're doing is taking however many rooms that you have that you rent out with a kitchen, you multiply that number by 100, because that's how much you bring in, right? If I said, oh, we rented out 17 rooms, how much money would that be? You just multiply 17 times 100. Yes? Right? Mm-hmm. Well, the same thing is for y. However many rooms we rent without a kitchen, we're just going to multiply that number of rooms by 80. And we know that the revenue, the total of the revenue, is $17,000. So now, ladies and gentlemen, we have created a system of equations that is just like what we have done before. So we just need to pick a variable to solve for. I'm going to pick for x. So I'll say x is equal to negative y plus 200. Does everybody follow me on what I did up top? Yes? And then we take that and we plug it into our other equation. So I have 100 times negative y plus 200 plus 80y equals 17,000. Apply distributive property. Combine like terms. Does everybody see what I've done so far? And now I'm just solving for y. So I'll subtract 20,000. So I have negative 20y is equal to a negative 3,000. Then, to solve for y, I'll divide by negative 20 on both sides. And I get y equals 150. So now I know that the total number of rooms that have or that do not have a kitchen is 150. Now to find the value of x, I'll plug in 150 in for y. So I say x equals negative 150 plus 200. X equals 50. So therefore, the number of rooms that have a kitchen is 50. And the number of rooms that do not are 150.
So in this problem, what it asks is, it says English is spoken as the first or primary language in 78 more countries than Farsi is spoken as the first language. Together, English and Farsi are spoken as a first language in 130 countries. In how many countries is English spoken as the first language, and how many countries is Farsi spoken as the first language? So, guys, remember the first thing we talk about anytime we're dealing with word problems, we need to make sure we define our what? Variables? Variables? Variables. You need to understand, what are you solving, right? You don't know, you can't do a word problem if you don't know what you're trying to solve for. So we look at the end of the question, usually tells us what they want us to look for. They want us to know, or they want us to figure out, and how many countries is English spoken as a first language, and how many countries is Farsi spoken as a first language. So they want us to provide us with 2 different answers, right? Right? Right. So what I need to do is I need to write up, how can I represent how many people speak English as a first language, and how many people speak Farsi as a first language. Farsi, whatever. Okay. So I can say X. What do you want X to represent?
The number of people that speak English.
Okay. As a first language. O is the number of countries that speak and then we'll have Y equals the number of countries that speak Farsi. Okay, follow me? Are we cool with that?
Yeah.
That's the hardest part. Once you guys can get to that part, all you need to do is now go back to the problem and see how can I solve the rest of this. So I go back in there and I'm going to read. It says, one thing, it says together. Together tells you what operation. Add, subtract, multiply, divide, add. Together, English and Farsi are spoken as the first language in 130 questions or 130 countries. It's a language. Just know it's a language. Well, hold on. So it says X plus Y, the number of English speakers plus the Farsi speakers equals 130 countries. Right? Number of people that speak English, or number of countries that speak English, plus the number of countries that have speak Farsi equal 130 countries. Right? So it says right there, together, English and Farsi are spoken as the first language in 130 countries. Then, what else do they tell us? Where else is there something else we can write? Well, it says English is spoken as the first or primary language in 78 more countries than Farsi. So how do I write 78 more? Does that tell you, what does more tell you to do? Add, subtract, multiply, divide? Add 78. So if I'd said, if I did Y, right, Y plus 78, that would equal X, right? Right? The number of Farsi countries plus 78 would equal the number of English countries. Now, obviously, ladies and gentlemen, this doesn't really help me too much with solving that problem. But what I can do is that I can rewrite this. If I, instead of writing Y plus 78 equals X, let's get our X and Y on the same side so it looks like this. So I'll subtract the X on both sides. So I get negative X plus Y plus 78 equals 0. Subtract 78 to the other side. So I get negative X plus Y equals a negative 78. Okay, why do I want to do that? Well, what have we been practicing this whole class? We've been practicing elimination by either subtraction or addition. So we've been practicing elimination by subtraction or addition. Well, here, I can eliminate these by simply doing what? I can eliminate the X variable by simply adding them up. So when I add these two equations up, what I get is 0x plus 2y, and then equals, let's see what it's going to be, 22 plus 3 is going to be 52. Divide by 2. Y equals 26. So that means the number of countries that speak Farsi are going to be 26. Then how do you figure out what X is? Well, just plug 26 in for Y equals X. So you have 104 countries equals X. So that's how we're English speaking. Do you guys see that? Okay, it's coming.
So, ladies and gentlemen, when doing a word problem, all right, there's a couple things I want you guys to think about because you are going to have a word problem on your quiz or your test, which is actually going to be next class period. So when doing a word problem, there's a couple things I want you to ask yourself. First of all, read through the question completely. Then I want you to ask yourself, what is it asking me to figure out? What is it asking me to find? All right? Then the next thing I want you to do is, usually when you're trying to find something, in a word problem, what we're doing is we're trying to create an equation or create a system of equations in this case. So you need to figure out what are your variables going to be that you're going to solve for, right? Because Wendy, you can put your backpack off your desk. When you're solving, that means you want to find the value of a variable, all right? So let's read through this equation or this problem. It says, Priscilla sells stuffed animals at a local craft show. She charges $15 for small ones and $20 for large ones. She sold $350 worth of animals. After the show, she noticed that she sold 20 stuffed animals. How many were small and how many were large? Now, usually the question that you need to solve comes at the end of the problem. So what is it in this problem that we're trying to figure out? We're trying to figure out how many small animals were sold and how many large animals were sold, right? So do we know what either one of those are? No. So let's set up a variable for each one. So it doesn't matter how you want to do it. I'm just going to say, let's have x equal the number of small stuffed animals, and y equals the number of large stuffed animals. Is everybody following me with that logic of thinking right now? You do not need to know how to do any kind of systems of elimination, graphing, all that. All you guys need to do is just determine what is the question asking, and then what are your variables that you can set up. So does everybody see? I do not know what the large are, and I do not know what the small are. So what do? I assign them variables. And when you guys go and create your word problem, I am going to expect you to, if you're going to be using your variables, I expect you to tell me what those variables represent. All right? So when you're doing your problem, you're going to want to do it just like this. Now, the next thing we need to look at is it says, write a system of equations that represents a situation. So first of all, if I have two variables, how many equations do I need? 2, right? Right? For every equation, or for every variable that you're going to solve for, you have to have an equation. So since I have 2 variables, I need to create 2 equations. The other thing that tells me I need more than one equation is it says write a system. If you guys remember, the definition of a system was when we were solving for 2 or more equations. So I need to create 2 or more equations. But before we even get to that, let's just see if we can figure out one, right? Let's not get carried away. So I'm just going to kind of read backwards through my sentences. So we already kind of covered out what we didn't know. The next sentence said, after the show, she noticed that she sold 20 stuffed animals. So do we know how many large or small? No, but we know when we add them together, we get what? How many are sold? 20. Wendy, could you please put your head up? So we know we can write an equation, x plus y equals 20. OK? X plus y equals 20. That's one equation. Now, what else other information are we provided for this problem? We're provided that she sold $350 worth of animals. That's kind of cool. And she charges $15 for the small ones and $20 for the large. Does anybody have an idea how can I write an expression for charging $15 per small one and $20 for the large? Yes? Plus 20 what? Where? Right. Right. Oh, OK. All right. Multiply by 20. OK. You actually went like kind of a little bit step further than you didn't have to. Did you only have one equation? OK. So what you need to do, rather than multiplying by the 20, which you did, you actually want to create a different equation. This is where I'm going to cover the x plus y equals 20. But you're right on track with the 15x and 20y, right? Because 15x tells you what operation are you doing? 15x and 20y is what? Multiplying, right? So you're multiplying the number that you sell times how much you charge for them. So you could say 15x plus 20y. So for every one of these animals that you sell, you get $15 for it. So repeated addition, we write as our multiplication, right? Because if you sold one, how much money do you get? $15. If you sold, so for the small animals. So if you sell one small animal, how much money do you get? 15. If you sell 2 animals, how much money do you get? 30, right? It's repeated addition, which we go with multiplication. But this amount equals how much did she make? 350. All right. Now the main important thing, now that you kind of know what we're talking about, two variables, you know you're going to have to do two equations. So you just want to separate that out, okay? Because one is talking about numbers and the other one's talking about cost. So you're going to want to separate them out. So now, do we have two equations with two variables? We're looking good, right? Can we solve this by either substitution or elimination? Yeah. What would probably be your preferred method? I'd probably like substitution well. And I would probably, I mean, it doesn't matter which one you substitute for. Let's solve for x. So I could say x plus y equals 20. Solve. So I get x equals negative y plus 20. Now, let's plug that into the other equation. So 15 times, instead of x, I'm now going to substitute in this value. So I have negative y plus 20 plus 20y equals 350. Okay? Distributive property. Negative 15y plus 300 plus 20y equals 350. We can combine our like terms. So we get 5y plus 300 equals 350. Subtract 300. 5y equals 50. Y equals 10. Right? So now remember, guys, go back up to your original equation. If you know y is 10, what does x have to be? This one's a pretty basic one to do, right? 10. So you could say x is equal to 10. So the last step that I want you to do for your word problem, because a word problem, it's a lot of steps. It's a lot of work to be able to read through this. So what you want to say is Priscilla sells 10 large and small stuffed animals. And the reason why we put it back into a word problem is, does that make sense in the context of the problem? Our answer, y and x don't make sense. But when you say, oh, she sells 10 large and 10 small stuffed animals, does that make sense? Well, it's into the context of your equations, then yes, that's going to make sense. Okay? And remember, you can always plug 10 in for x and y back into your equation to be able to check your work as well. Anybody have any questions on what I did? No? Everybody feels good and confident and lovely? All right, cool.